Welcome to the lecture on the partitional clustering algorithms. So, as we had told earlier, what partitional algorithm does is to group points into clusters, clustering algorithms into clusters, and then evaluate how good are they. So, as an example, let me explain this. Suppose there are points like this, and one possible into 2 cluster is this, another possible is this. Of course, this is preferred over this because this has a better intercluster separation and intercluster homogeneity. Okay. So, that is what it will try to achieve. So, there is one greedy algorithm. What it does, instead of trying out all possible partitions and finding which one is the best, it kind of starts with some initial guess of the partition and then refines it. This algorithm is called the k-means clustering algorithm. So, the basic idea is start initial partition, then refine the partition over iteration. So, this is also a iterative algorithm, whereas the hierarchical ones are single sort. Okay. This is a iterative algorithm. Or over iterations. Okay. This is the idea. So, you start with some initial partition and then refine it. Let me tell you. So, the name k-means is because it work with mean value, the average value of a cluster, and there are k such means that determine the answer. So, if you want to into k groups, k clusters, you have to accordingly choose value of k. Choose k. Note that one very important problem is in clustering is that nobody really knows what the number of clusters are, what is the natural number of clusters. Given the data, nobody really knows. So, maybe I ask you a question. Suppose I have say points like this, say so, what is the number of cluster? Is it 2 or is it 4? Okay. So, that is a no guideline to know what is the natural, what is the number of cluster that are naturally there in the data. So, what we do instead is that we, depending on the domain, we choose a user defined k. All right. So, for the k-means algorithm, first how many clusters you have to know, k value you have to know. Then I will explain you. You do the following. So, let me draw the picture again. So, you are given p 1 to p n points, say cluster them into k equal to say 3 groups. Choose k random points as initial cluster seeds. Just out of these n points, just pick up k points, randomly pick up k points. So, suppose this is 1 point, this is 1 point and this is 1 point. Okay, this I have actually I am lucky that I have got the 3 points in 3 cluster. They may not happen, all the 3 points may come from the same cluster if you randomly choose them. Okay. So, okay, let us be optimistic. So, I have 3 points initially chosen. Now, I do the following. I make 3 bins, 3 containers, and these initial points that I have randomly chosen, let me call them as M 1, M 2, M 3. Okay. So, k equal to 3 here. Place these seeds, initial seeds in each of these bins. Okay. Place the seeds in this bin. Now, you go through your data points. Take the first point, see which of these seed it is closest to. You know the distance between 2 points, that is already defined. You see which seed it is closest to. So, for example, if your point is this, it is closest to this rather than this and this. Place it there in that bin. So, first point goes into this bin. Now, look at the second point, again see which M 1, M 2, M 3 it is closest to, place it in that bin. So, this way go through all the points and place them in the closest mean value, closest seed M 1, M 2, M 3. So, this is the So, what will happen after first iteration? So, your n points will get distributed in these 3 bins. Now, we will start the second iteration. Okay, let me properly draw it, so that I have some space to write. Wait a minute, sorry, I am just clusters. Say M3 are the seeds. So, place the P1, P2, P3 in their bins, whichever M1, M2, M3 is closest. Now, update the seeds. So, after first iteration you have distributed the points. Now, throw a M1, M2, M3. Take the mean data point, central point of all the points which in first bin, all the points in second bin, all the points, and those are your new M1 prime, M2 prime, M3 prime. The average point of all this. So, for example, M3 and say after first iteration this is one bin, this is one bin, this is one bin. You throw a M2, M1, M2, M3, take the center point of all the bin of each bin, take that as your M1 prime, M2 prime, and 3 prime. Bins. Okay. Now, repeat this step. Okay. Now, with this new bin again go through P1, P2, Pn, redistribute them. Again update M1 double prime, M2 double prime, M3 double prime. Keep on doing this till over 2 iteration M1, M2, M3 do not change much, they become fixed, they have converged. Successive iterations. Let me properly write down. is closest MK intermediate R is closest to Pi, the point which I am placing, repeat. So, repeat these two. And MK successive iterations. Okay. So, this is the K-means algorithm. So, what it does actually is it produces circular clusters, spherical cluster, because see it are placing to the closest. So, it tends to produce. So, if you have natural clusters like this, it will actually produce clusters like this. Actually, it can be shown that the K-means algorithm will converge to the point whose distance from the center, if you add them up, that is the minimum. Okay. So, take the cluster center, this is the minimum. Clusters, but it is very fast. Iterations, and it takes care of noise. Robust to noise. Okay. So, very simple algorithm, very simple. Let me illustrate with an example. Say 6. So, let us say I have this 6 points, I have this 6 points, okay. And then what I want to do is to cluster them into 2 groups. All right. So, k is 2. Okay. So, randomly choose 2 points. Let us see, suppose I choose this point and this point. So, M 1 is 0 1, 6 1. Here is one bin, 6 1 is another bin. So, now let us iterate. This point will come here, this point will go where 0 0, this or this, which is closest, this is closest. So, 0 0 goes here, 1 0, this is closest or this is closest, this is closest. So, 1 0 goes here. Now, 5 0, this is closest or this is closest, it goes here. 6 0 goes here, goes here. This is one. Okay. So, what is M 1 prime after first iteration? Average of these 3. So, it is 0 plus 0 plus 1 by 3 and 1 plus 0 plus 0 by 3. So, it is 1/3 and 1/3. This is M 1, M 1 prime. Okay. So, somewhere here. Look, the class seed has shifted. This one, it is how much? 5.9, something like that approximately, and y axis is 0 plus 0 plus 1 by 3. So, M 2 prime is 3 other 1/3. So, 5.9 and 1/3. So, it is something like here. Okay. So, now start the second iteration. So, 0 1 goes here, 0 0 goes here, 1 0 goes here, 6 1 goes here, 5 0 goes here, 6 0 goes here. So, what is M2 prime? Same, it will be same as M1 prime. Sorry, M1 double prime, I made a mistake. M1 double prime is same as M1 prime, because these points are same. Again, if you calculate mean same, you will get M2 double prime is M2 prime. So, over 2 iteration seeds are not shifted. Now, you stop. So, your final cluster is this is one cluster, this is one cluster. Okay. So, that is how it works. All right. So, thank you for today. In the next class, we will discuss about a density based clustering algorithm known as DB scan. Thank you.